Okay, composition of functions. Got half the class here today. A lot of people are gone. We got, let's see. So who sits here? Jared. Shout out to J Rod. No, he's what? He won't watch the video. Yes, he will. Why would you say that? Jens, why would you say mean, hateful things about people? Jens. Call. Oh. Teresa, we're sorry. We miss you. Terry and Braden. Elena, we love you. You're missing. Jill. Oh my goodness. It's optional Monday. Tristan's upset because she doesn't get shout outs. Very interesting. Yeah, exactly. So, yes, what do you have to say about this, Justine?
I said it's really hard to watch these videos and not know what the other people are saying. I know I'm not.
Lauren is going to sleep through the lesson because she already knows how to do all of it. She scoffs at our level of mathematics. She says, Mr. Gintz, please give me something more difficult. Let's step it up. Okay. Function composition. New, but not that difficult. Okay? New, but not that difficult. You have operations, addition, subtraction, multiplication. And then we have things like square roots, sine of, natural log of. And in fact, if you're wondering what calculus is based off of really kind of two operations. They are called the derivative and the integral. And so you learn other operations as you move along in mathematics, which makes it totally cool. Okay? But in this scenario, composition is an operation. We do it to functions. And it looks like this. You see f of g of x. That's what this means. It means f composed of g of x. And function composition is really defined as this. You could see it written as f of g of x. And all that means is we take x and we plug it into function g. And we get an output. The output is g of x. Yeah, yes, I do. Yes. Miss Nelson, if you're watching the video, shout out to you for the function machine. And Rhiannon misses you. I don't. All right, so then we I got over you a long time ago. What? She called me this weekend, Saturday. It was like 11 o'clock. She wanted me to sing the happy birthday song. She was celebrating somebody's birthday. She's like, hey, nobody here can sing, so putting you on speakerphone. So I can't sing either. She's like, I know, but you're the only one willing to. So, so anyway, so we sang the birthday song. All right, enough. YouTube listeners, you want to focus on math. So we take that g of x, we plug it into f. And then what we get out is we get out f of g of x. Yeah, you just put it through a couple functions. So here it says f of x is 2x minus 3, and g of x is x squared plus 2x, f of g of 0. So you take 0 and plug it in for g. And all of a sudden this turns to f of, well, g of 0 is 0. Yeah? And then you plug 0 in for f, and you get negative 3. Now we'll do g of f of 0. So first we plug 0 into f. We get negative 3. And then what do you plug into g? Negative 3. Negative 3 squared is 9, and then minus 6 is 3. All right, let us work through your confusion, Miss Lolly. All right, you will now. If you see it written as f composed, meaning this little circle here, you can simply just write as f of g of negative 2. These mean the exact same thing. Okay? So, Lolly, I'm going to start with the inside. The inmost parenthesis part is the -2. So I take that -2 and I plug it into G. It's saying to be plugged into G. So when I plug it into G, I get -2 squared, which is 4, plus 2 times -2. So we get 4 minus 4 is 0. So this G of -2 becomes 0 because G of -2 is 0. Now I have to identify f of 0. And I get -3. You guys try D, E, and F. Go. You got it, bro. For D, I got 35. For E, I got -5. So I'm going to take I'm going to take 1, I'm going to plug in for F. And I get -1. So then I take -1, I plug it back in for F. And I get -5. For D, you plug into F first. Uh, we will plug it into F once, and whatever we get for an output, we'll plug into F again. So it's okay to have 2 of them. So again, we treat this as F of 1. Mackenzie, do not laugh. You only encourage her. Okay? You don't laugh at my jokes. You can't laugh at Rhiannon. All right. Now what we're going to do is instead of being given a value, we're just given x. And so I will turn this into f of, instead of g of x, what do you think I write? What is g of x? X squared plus 2x. So g of x, this thing right here, it is x squared plus 2x. So now I plug x squared plus 2x in to f. And I get 2 times that x squared plus 2x minus 3. Because f of x is 2x minus 3. So we get 2x squared plus 4x minus 3. Booyah. So if you were to factor something out, which you can't because there's a 3, but maybe you could factor it as a more difficult trinomial, that doesn't necessarily mean it's simplified. It just means you're rewriting it. So for us to simplify will be get rid of a negative exponent, combine like terms, okay, cancel something off, get rid of a radical in the denominator. So we're okay here. Okay, the next one, g of f of x, I will take g of 2x minus 3. So g of x was x squared plus 2x. So now I will have 2x minus 3 quantity squared plus 2 times 2x minus 3. And when I square this out, I have 4x squared minus 12x plus 9 plus 4x minus 6. Or 4x squared minus 8x plus 3. Try letter I. I have 4x minus 9. You good? Okay. Are there any questions on that before we flip over to the other side? Nope, we're going to skip J. Okay, here we go. Here we go. So mine's written in blue and red. Yours is not. So you got to try to figure this out a little bit better. So what we want to do is we want to combine those pieces that we've learned, such as addition, subtraction, multiplication, division, and composition. We want to apply it to settings where we have a graph. And so if you look at the first one, I want to do f plus g of 2. And so you do f of 2, and you add it to g of 2. And so this isn't too bad. What is f of 2? If I plug 2 into f, what's the output? It is 2. And if I plug 2 into g, what's the output? Negative 3. This 2 or this 2? This one? Right here. The red is f. The blue is g. They are each piecewise functions. What? We should always be able to refer back to a piecewise function. I'm waiting. So if I plug in 2 to g, this is the graph of g, so I plug in 2 and the output is negative 3. Has a height of negative 3. Okay. The next one, good question, is g minus f of 0. So I do g of 0 minus f of 0. What is g of 0? G of 0 is 4. And what is f of 0? 1. Now I have f of negative 1 times g of negative 1. F of negative 1, 1. G of negative 1, 4. F of g, or f divided by g of 0. I take f of 0 and divide it by g of 0. F of 0, 1. Divided by what is g of 0? It is 4. And I get 1/4. Now, let's do composition. F of g of 1. So f of g of 1. Composition is where we take a domain value and we plug it in and we get an output. That output becomes the input then for f. So we end up plugging things in twice. So g of 1, 4. So this becomes f of 4 because g of 1 is 4. F of 4 is 4. You try the last one on your own. If you plug in negative 2, you get 4. I'm sorry, you get 1. Sorry. I was looking at the wrong graph. And then g of 1 is 4. Okay? Not too bad, huh? Let's do the last piece. We would then like to be able to look at their composition and then identify the domains. And so we can't simply look at, for example, we can't say, well, the domain here is all real numbers, and the domain here is x not equal to 0, and so therefore x can't be 0. You know, we can't look at the domains that way. We literally have to compose them, and before we simplify, we state the domain. So we'll show you an example. Here it says f of g. So f of g of x is equal to, I take what g of x is, and I plug it in over here. I get 2 over 3 minus x. Is there any simplifying? No, there isn't. So I will identify the domain. X can't be what number? 3. Now, if you notice, that doesn't come up in any of the original domains, does it? So you literally have to look at, it ends up being the output of G cannot end up giving you, say, 0 for the new domain. You know what I mean? So let me give you an example where, you know, a little bit trickier. If I had f of x is equal to x squared and g of x was equal to the square root of x. Okay? Now, f of g of x, I would take that square root of x and I would plug it in over here and I would square it, right? Now, I have to look at the domain before I simplify it. Okay? If I look at the domain right now, all right, what is the domain of the square root of x? X greater than or equal to 0. So 0 to infinity, right? Now, if I did square this, what would you come out with? You would come out with x, and you would say that domain is all real numbers. You have to state the domain before you simplify it. Before you simplify it. If you don't believe me, all you have to do is just take your calculator and go into y equals and type in parentheses the square root of x, that quantity squared. And when you graph it, you can see that you don't get the full graph of x because negative values are not in your domain. See that? Whereas the graph of x, if you watch now, it'll just complete the entire graph. It does give us the whole thing. But that's not what this graph looks like. F composed of g only looks like the right side, not the left side. Okay, so consider the domain before you simplify. Okay, last one, g of f. So I'm going to take f, and I'll plug it in here. And I end up with the square root of 2x minus 6 minus 2. Does that simplify? Can I combine some terms together? Yes, so I will get the square root of 2x minus 8. Now, we should consider the domain before we simplify it. And it really doesn't make a difference in this example, but I just want you to understand that in some situations it does. And so, anytime you have a square root, you should take what is on the inside of the square root and set it greater than or equal to 0. You can see in this situation that you have 2x minus 8 then is greater than or equal to 0. So 2x is greater than or equal to 8, x greater than or equal to 4. So your domain is going to be from 4 to infinity. So always consider a domain. Whether you did this one before or after, it wouldn't matter. But you can see that in the other example with the square root and the x squared, where there is simplifying that happens and kind of changes the way the function looks, that does change things. Okay. All right. So this shouldn't be that bad of an assignment. You see that we actually went through a lot of problems if you consider the front as well. And so here we have it. Your assignment is that page. And we had 25 minutes in class, by far the most time any class had to work on their assignment. Their class had about 12 to 15 minutes. So, but you guys are the most intelligent of classes, and so therefore we're able to fly through these notes. So I am almost done with the study guide key, just ensuring that there are no mistakes with it, and I'll be running copies of that immediately. So please try to keep up with your homework, because you do have time to ask questions on Wednesday. That's really what I'm devoting Wednesday towards, is, I hope that you come up with those questions. But I do hope that you get your study guide questions taken care of as well. So start working on the stuff you know how to work on.